everyone, my name is Rajneesh and I am a graduate student at NC State. Today we are going to talk about the importance of clean water and I will show you how we can clean a really dirty water using some simple steps. And this water can be used for various purposes such as irrigation or gardening. Okay, so let's get started. First of all, before entering the lab, we need to wear proper protective equipment, which will ideally include a pair of gloves, eyeglasses, and a lab coat. Also, make sure that you are wearing a full length pant and shoes. We are here at NC State Undergraduate Laboratory and we will be performing this activity in a safe lab setup where we will have everything that we need for this activity. Before starting this activity, let me show you all the materials which we will need for this activity. We need a wastewater sample to clean, which we will prepare by adding soils, dirt, vegetable oil, soaps, and some coloring. Wastewater sample can also be collected from a local source. Additionally, we need at least 3 glass beakers, some filtration weights, and some few chemicals to complete this activity. A complete list of all the materials have been provided in your guidelines, which you can see from there. So all the chemicals that we will use are being shown here. We have activated charcoal on the left, then aluminum sulfate in the middle, and calcium oxide on the right. Now I will go ahead and prepare the wastewater sample which we need to clean. I have taken a 2-liter glass beaker which is half filled with water, and into this I am adding vegetable oil, some soap, then I am going to add vinegar for some smell. Next, we will be adding food coloring to give it some color. And then we will add lots of dirt and soil to make it look like a real dirty water which we can collect from our local source. Finally, we will add kaolin clay, which is basically a superfine soil particles which will dissolve in water and is really difficult to clean. After adding everything, we are going to give it a nice mix. We will stir it for a couple of minutes so that everything that we have added are mixed very well and they cannot be separated easily. Again, I am emphasizing to mix it very well so that everything we have added are mixed well and we have uniform dirty waters. Now we will go through our first filtration step, which I have prepared using a Buchner flask, Buchner funnel, and kept a cheesecloth on top of that. I will slowly pour the wastewater sample over cheesecloth, which will filter out all the bigger size particles. Sample for further treatment will be collected in the bottom of the flask, and this process actually simulates a real wastewater treatment plant where all bigger and coarser particles are screened out before entering the plant. You see, these are all the materials which we have filtered out in previous step. If they enter a wastewater treatment plant, they will damage the piping system. I left the wastewater sample to settle for 5 to 10 minutes before this activity, and after 5 to 10 minutes all immiscible liquid will float on top of the water, which I will filter out using a pipette. After few minutes I have skimmed off most of the oil and soap from the wastewater sample, and our sample is ready for further treatment. In an actual treatment plant, this liquid will be separated as an overflow from the wastewater. Now our sample mainly contains fine dirt as well as smell and color, which are not easy to separate using simple physical methods. I will transfer the sum of wastewater sample in a different flask, and into this I will add some chemicals. First I will add 1 gram of alum or aluminum sulfate, and then I will add a small amount of calcium oxide. The purpose of adding this chemical is to agglomerate all finer particles into bigger lumps, which will then settle down at the bottom of the flask due to gravity. After adding all these chemicals, we need to stir the sample for 2-3 minutes for uniform mixing and all the particles come in contact with each other so that they can start forming flocks very soon. After mixing it completely, I will let the sample settle down for at least 15 to 20 minutes, more the better. And in the meanwhile, I will prepare sand filtration bed and charcoal filtration bed, which we will need for further treatment. You can see our wastewater sample has become less cloudy and dirt particles have settled down at the bottom. And I have made 10 to 15 small holes in the bottom of plastic cups through which water will come out. Now I will slowly pour the wastewater sample over the sand filtration bed. Treated water will collect in the flask kept at the bottom, and impurities will get stuck between sand particles. As you can see, this step will remove almost all dirt particles, but it cannot remove the color and smell from the water, for which we need our next filtration bed. Next, I will pass the filter water from the previous step over a charcoal filtration bed for our final treatment. Charcoals are superfine particles with very high surface area, which will entrap even the smallest of particles from the water. However, we will need multiple pass over the charcoal bed to completely clean the water. Okay, so after 3 to 4 passes over the charcoal bed, our filter water looks really clean, transparent, free of any color or smell. But please note that the final filter water is still not ready for drinking. However, this water can be used for various other purposes such as agriculture, gardening, or it can be returned back to a lake or a river. We have provided an observation table here which will be very helpful when we do our activity. During the course of our activity, we will make some observations regarding the clarity, color, order or the materials that we remove during each successive step of filtration. Apart from that, I have also listed down some questions which will make you think and further enhance your knowledge about this activity.